I'm going to do video 4 of the induction heater series, and I just wanted to show a video of this before I put it into this case back here with the new amp gauge and volt gauge on it. And I've mounted my heatsink to the power supply. Here you can see the screws that hold it onto the power supply, and those are screws that came from the Chinese circuit board, and they fit right into the power supply nicely because they're already the right thread. And over here I've added a shunt for a volt and amp meter, and it's mounted to the same circuit board material with the copper removed, and the wires just run over here to the amp gauge on the front. Now I wanted to do a little demonstration of the heating capacity, so I'm going to turn it on. And I've got this piece of metal here that's pretty good size, and it's cold. I'm touching it. And then the top of it is a little bit of water. Now I'm going to put this coil on there and see how long it takes for it to heat up. Now right now this is running at about 25, 26 volts, 24 amps. And that's pretty much max power for it. And there it goes, you can hear it starting to sizzle. So it boils it pretty fast. I mean, it's only a few hundred degrees, but it's pretty fast. And I wanted to talk about another change that I made. Now, all these coils, these cables and coils and everything are all part of a tank circuit. And I've determined that this circuit runs its best optimal performance with a 1 microfarad cap. Now what I've done is I bought 10 of these 0.1 microfarad 1000 volt caps, and I soldered them onto these brass rails. They're on each side, soldered on from each side, and because they're so large and their value is less, they actually run way cooler than these original Chinese capacitors over here, which were just 0.3 microfarad for a total of 0.6 microfarad. Now, this is another capacitor here that's available on eBay. It's a 2 microfarad 1600 volt cap. Now that cap worked quite well when it was used on the circuit. The only thing was the power factor was too high for the power supply. You would need a larger power supply to use that capacitor. And of course, if you use that one, the capacitors run hotter and these coils run hotter. A 5-minute test at full power, the capacitors here stayed cool. These coils heated up to about 140 degrees Fahrenheit. Now, when you add capacitance to the circuit, it actually lowers the frequency. So we put a meter on it, and right now it's running about 117 kilohertz, where before it was running a higher frequency. But it's kind of a trade-off. You have to decide, how much power you want, whether you want to use all big coils or small coils. And with these capacitors, this 1 microfarad capacitor right here, that works best with all around size coils, up to 1 inch, maybe even 1.5 inches. When you get the larger coils, the frequency drops very slightly, but not that much. It's pretty much stable, and everything works quite well. I'm getting about 650 watts out of it, and I really only wanted 500, so it's all good. And I'll probably post another video when I get this all in this whole thing here mounted in this case back here, and with the graphics and everything on it, and maybe I'll do a little demonstration on some of the coils and how to wind them.